Alright, so second video I'm going to put together for you guys for distance learning. What I've got here is the table all cleaned up, everything all taken off, all the vices removed, so that you can, so I could get everything really nice and clean and get set up to make some of the parts for the manufacturing class. So what I have installed here is an Edge Technologies tram tool. I use this maybe once a year and just use it to make sure that the spindle is perfectly parallel and in line with the table, or I should say perpendicular. So just to make sure that the spindle isn't pointing forwards, backwards, or tilted to one side or the other, because it completely wrecks cutters and it wrecks surface finish quality. So the tool, my tripod is just a little big for in a small shop. So the tool just gets installed in the spindle, and the first thing I have to do is calibrate it just by having one of the indicators touch the magnet and the other one come off the side of the table. So what I'm working towards is I'm just going through the instructions. This is the super nice case that it comes in, and this huge piece of aluminum is going to end up getting bolted down to the machine and machined with a whole bunch of holes for dowel pins and bolts. It's going to sit right flat on the table. Once that's done, I'm going to get started on making some of the keychains that you guys drew and designed in our first week of distance learning using Onshape. So I got to get this machine set back up so that we can get to making some of the parts that you guys worked hard to draw on CAD. So first thing you got to do is put this calibration magnet down on the table. Turn this on to try and get both angles. And then I have to lower this tool down until it reads 100,000ths of an inch. Try to be as accurate as I can. Looks pretty good right there. Move, just lock that spindle in place. Now I can lift up the plunger to be kind of careful. Rotate this. Lift this back up. And then adjust the needle on this guy. Keep that if it's in the way. And adjust the needle on this guy until it reads 0. So now that reads 0. Spin it around. Bring it back over the other way. Put it down on the magnet. And adjust it this a little bit. We're going to just do that a couple times until we get the most accurate reading. We want it to say 0 on both. Maybe I can bring this in a little closer. Try like that. So this one at rest is reading 0. Bring it over. Both reading 0. That's pretty good. We're getting there. I could try to do a little better though. Try to get it bang on. Sometimes helps to just okay. Back over. And this time we're going to get perfect. It's calibrated. So now the goal is to, now that this tool has been calibrated, the goal is to make sure the table is clean where you're going to test. Easiest way is usually to run your hand along the surface. If not, you can take a stone. This needs to be cleaned quite a bit before it gets used. But I can use this and stone the whole table, and before I put that large sheet of aluminum down, I will. But for now, you can just run your hand over to make sure there's no like nicks or bumps. And all you got to do now is to press this down 50,000ths of an inch. And lock the table. And you can see, spin this around, you can see that where this is at 50 thou, this one is at almost 75. So that means that over that, whatever, I think it's 6-inch gap, but it's probably less, it might even be 5. There's a 25 thou difference. So that means that the head of the spindle of the CNC, just from use over a number of hours, is now tipped. So this side is lower, or sorry, this side is lower because the needle went up higher. So it's like this, which makes for a poor cutting finish and creates these lines. So you can see those lines, but you can actually feel them. If you're making a part and you can see them, that's one thing. But if you can run your fingernail over it and feel it, that's no good. That's got to get fixed. So that's what this is. That's what this tool is for. Once I get this completely square and level in the X direction and then in the Y direction, then I can bolt that big piece of aluminum down and work on starting to make something from it. So now 19 mil wrench to adjust and get that needle and this needle to be at the exact same spot. All I've got to do is loosen these two big guys on each side. And there's one back up there and there. It's kind of gross, but you get the idea. Once those are loosened off, there is a large adjustment pin. There's a large adjustment bolt that goes right in the middle, and that lets you move it in and out. So we got 1, 2, 3, 4, and then the actual to turn it all is this big guy back here. That will adjust and move the whole thing this way, and then this guy right here loosening off will adjust the whole machine ahead this way. So you do one at a time and you just keep on going nice and smooth and slowly until you get it as accurate as you possibly can. So now the process is pretty straightforward. It's just a matter of repeating until I get both of these gauges to read the exact same, and they're not, this direction isn't anywhere near as out as it was this way. So the spindle was tipped quite a bit to the side. Hopefully it won't take too long to get this sorted out, and then so this adjustment here, once these are loosened off, should let me so I may be totally wrong. Yeah, I was wrong. This moves the whole head assembly in and out. I do this like once a year, so I should know, but I didn't, and that's okay. We don't all have to be perfect. Getting close. Maybe just a tad bit too far. That's 41.2. And that's on 41, so that's 1,000 of an inch off in this direction. So let's try to creep it up on it again and see if we can get it. 41. 40, that's 42. 41. That's about as good as it's going to get right there. I'm going to take the pressure off of those and move. No, looks pretty good. So both gauges have managed to stay. 41, 2, 3, or sorry, that's 37, and that's like 36 and a half, so half a thou is more accurate than I can machine with this one. So that's pretty damn good. Cinch them down and take a look. That's awesome. Perfect. So now this tool can be taken out of the spindle, put away. Last thing I should show, my shop tour video. I just had all my tools all sprawled out. These ones I haven't sorted out the tool number for yet, but once I do, I'll write it down and set it up in this rack. This has been a project I started a long time ago and just never really got my button gear to finish, so I got made fun of for how disorganized I had all my tools lying around. So now, slowly, little step by step, I'll just try and make things a bit better.